Hi, welcome back.
Hello.
We're doing the weird recordy thing again, where it's not just my hands, but it's like the whole package deal today. We're continuing with complex numbers. Today is multiplying them. And we had the thing that looked like this. Okay? So let's recap what we already saw with the complex numbers. We saw yesterday how to add them. So we had stuff like this. Just making up some numbers. And we discovered pretty quick this was just like combining like terms of polynomials. And so I got to add the real bits together, I got to add the imaginary bits together, and I would have answers like that. Okay, right? That felt really good? Easy enough? And then we also took a moment to, let me make that a little rounder, to talk about how we multiplied just the imaginary parts together. We multiplied them as if the I were a variable like x, so I times I becomes I squared. And the other thing you have to remember from here is that whenever you have an I squared, you should replace it with a -1 and then continue with number things. Right? Nothing too crazy. We're okay with this? Cool. So let's take both of these concepts and hi, come on in, your stuff is back there. And let's talk about how we multiply these things together. We ended the day yesterday going, some of you may have an idea about what you might want to do. So let's hear it. What were your ideas?
First, outer, inner.
Foil.
Foil it. Distribute the thing. First, outer, inner, last. Pretend they're polynomials and then just do the distribution thing. You're absolutely right. That's exactly what we do. So 3 times 2 is 6. 3 times -4 is -12. 2 times 2 is 4. And 4 times 2 is 8. And there's an I squared. Combine like terms. Easy enough to do. So 6, there's 8. And then we replace the I squared with a -1. And we continue. More stuff to do. And we have some new like terms that showed up. And there isn't anything more I can do, so I'm done.
So that's your answer?
That's the answer, that's it. Right? Complex numbers we are discovering are very badly named. They're not complicated at all. Why do you name that way? Please, someone invent the time machine, go back in time, change the name. We'll wait for you.
Not complex numbers.
Not complex numbers. Okay. So either you haven't made the time machine yet, or you did it and instead of changing our reality, you have spun a new universe with the, it's now called not complex numbers. Good job. He's like, thanks. That's it. That's all there is to this. Can I erase? Are we good?
Mm-hmm.
All right. I have one last thing to say before we call this done today. There wasn't much on this section. All right. It was this thing. Back in Algebra 1, when you were first learning to do quadratic-y things, you may have played with the quadratic formula that x equals -b, and you had this big ugly thing under the radical, right? And anytime you got a negative under there, your teacher would go, "You did it wrong. It's not supposed to be negative. You can't have negatives under there. Fix it," right? They told you it was wrong, right? You remember that? Mm-hmm. Here's the thing, is they were kind of lying just a little bit. You could totally have negative numbers under the radical. We just couldn't deal with it then because the only numbers we knew about were the real ones. And now that we've put fairy wings and glitter dust on our numbers and made them imaginary, thank you for the pity laugh, you can totally handle the square root of a negative number. Here's how we do this. I'm going to break the square root of -4 into 2 numbers, -1 and 4. And then I'm going to break this one radical into 2. And so we have the square root of -1 times the square root of 4. Square root of 1, totally easy to handle. Just replace it with an I. Square root of 4 is?
2.
Or?
-2.
And I'm going to put that little plus or minus symbol in front of it to tell us that it's either the +2 or the -2. Okay? And that looks weird because if you don't see the dot for the multiplication, it looks like I'm saying I plus or minus 2, which isn't what I'm saying. I mean I times plus or minus 2. So we're going to write it with the number in front, no symbol between the number and the letter, which then tells us that it's +2 times I or -2 times I. That's 2 answers.
Could you write it separate?
Sure, if I wanted to write it separate, I could, and it would look something like that. I might want to consider putting the squirrely brackets so that I'm saying that it's the collection of these numbers and not like I mean you to graph it on a piece of graph paper. Great question. I see some thinking faces. Do you have a question?
Oh, I just don't understand. If we're trying to get -4, why would we do -2?
Why wouldn't we do -2?
Well, why would we? If it's -2 times -2 equals a +4.
Oh, great question. Because right here, when we're talking about the square root of +4, -2 is one of the square roots of +4. Because of what you just said, -2 times -2 is +4. We started with a -4, but we broke that negative away from it by thinking of -4 as -1 times +4. Because I know how to handle square root of positive numbers, and now I know how to get rid of square root of -1 and turn it into a much easier looking symbol. And so that's why we end up with a -2 sitting here, because that -2 is really the square root of +4. That was a wonderful question that made my brain hurt, and I loved it.
Oh, my fingers. No.
That was a great question. All right. Let's do the next example here, because I know that a few people are still kind of digesting. The only way to make this thing more complicated is to make the negative number like more negative, more big. So I need, please, a fairly large, keep it under 100.
100.
67.
20.
No.
25.
65.
20.
65.
Okay, I'm ruling out 13 because it doesn't have any perfect squares.
65. 65. 65.
65, 20. 20 is one of the questions on your homework. Chief
Oh.
Lala. Let's do 24. I know some of you are asking, like, because you're calling like 65 and 100. 100 again is really easy. It's kind of ends up like 4. Yes? Okay, thank you.
Interrupted.
So catch us on YouTube later. Duck down if you don't want to be seen.
I'll just cover it.
She'll cover it. Okay, good. Thank you to that camera person. Camera lady. Camera student. Okay, we're figuring
I
out
should
this
give a
one.
shout out.
I ruled out 65 also because it doesn't have any perfect squares in it, which we need in
man.
order to make this happen. All right. We could have, it ends up like 4. Anyway, so the first step remains the same. I'm going to separate this into a -1 times 24. Next step of the game remains the same. I'm going to pull out the -1 so I could turn it into an I. And now I'm left trying to figure out what the square root of 24 is. And
Wow.
from here, you think factor pairs. You think two numbers that multiply together that give me 24. I'm going to scribble some of them down over here.
1 and 24.
Okay, 1 and 24, 2 and
12,
12,
Not 3 and 8.
4 and 6, 5 doesn't work, and then 6, I'm starting to repeat myself, so I'm going to be done. All right, I have a lot of factor pairs. When we're doing square roots, this one's not helpful, okay? Because I want to get rid of the 24. I don't want to see 24 anymore. Now I need to pick from these 3. The one I want to pick is the one that's going to be the most useful. It's going to be the pair that has a perfect square in it. It has a number that has a whole number square root.
4 and 6.
4 and 6, because the square root of 4
Yeah.
is
2.
or -2.
Or negative.
Okay, great question. What about 2 and 12? Does 2 have a whole number square root?
No.
1. 1 times 1 is
1.
not 2.
Stupid.
You're thinking 1 plus 1. Yeah, which is totally fair. But with square root, you're looking at multiplication being what sticks them together. And then with 12,
6 and oh no.
6 times 6 is not 12. 6 plus 6 is 12. And square roots deal with multiplication. They don't deal with addition. Okay? So it's this one. Because 2 times 2 is 4. All right, so now that I have those two written down, I'm going to separate them. There is a flashy thing happening I can see on the whiteboard. If that's you, please put that down. All right, I have the, okay, plus or minus again. Again, this looks weird, so we're going to shove all the numbers in front, all the letters in back. It's very discriminatory, this whole writing math thing. We like to write it this way, even though the square root is stuck somewhere in the middle, and that could potentially be ugly and weird. But we write it this way so the I is at the end, so that this value looks like that. It looks like the imaginary part of a complex number. Questions?
Nope.
Comments?
Mm,
You can leave them in the comment section. I'm kidding. Suggestions.
shoes.
Please don't tell me wear makeup. So nothing, we're good on this?
Yeah.
Did anyone want to see another example, or is that good enough?
Let's go see one more.
One more? Sure. Do you want to make up the number? A 320 or 20? That's one of your, no, it's a
48.
48. All right.
2 days.
First step of the game is separate
it's
the
getting
negative
tired.
out with a -1. Separate out the -1 into its own square root. Exchange that for I. None of that required any thinking. Okay?
Mm-hmm.
Then we're going to take 48 and we're going to think of all its factor
Factors.
pairs. Things we multiply
2 and
together
24. 3. I know.
to get
4 and
to,
12. 6 and 8.
and we're repeating
And then
ourselves
repeat.
now. Okay, so we done. This one, never helpful for square
Nope.
roots, so we're just going to throw him away.
6 and 8.
Okay, does 6 have a whole number square root?
Doesn't it?
Oh, no, 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 no,
Does 8
no.
have a
4
whole number
and
square root?
12.
Yeah, so it's 4 and 12 because 4 has that whole number square root. There's 4, there's 12. Breaking those apart.
Then you move the thingy-majiggy. Don't
Okay, here's the
discriminate.
question I have for you though. Are you done and how do you know?
Wait, don't you have to have a positive or a negative?
Oh, yeah, you're right. Okay, I don't know if I'm done, but let's check. The 12. Does 12 have factor pairs with a whole number square root?
Yeah. No. Oh, yes.
Yes. So I'm not done because there's something more I can do. So, now I've already got a plus or minus happening, so I don't really need to write it again. Okay? 1 is more than enough. Bring that guy to join this 2 over here. You know what this tells me? Well, yeah, that I'm done for 1 because of 3. But this tells me that right in here, right here, I missed 1. I forgot or never had memorized, and that's probably what happened, that 48 was divisible by 3.
Dang it, man.
It's okay because I still got to my answer. I just had to do this thing again rather than doing it in one step.
So in other words, we have to know our factors.
Knowing your multiplication table is helpful. You don't have to know your multiplication tables because you can play this game. 48 divided by 1 is a whole number. That's a factor pair. The thing you divided by times was the answer you got. 48 divided by 2, answer is 24. 2 and 24 are factor pair. If I had done 48 divided by 3, I would have seen 16, and I would have known 3 times 16 is a factor pair. And now notice you have 2 factor pairs that work. Pick whichever one you want. Hint, go with the one that has the biggest perfect square. It makes it fewer steps.
4 and 12? No, 3 and 16.
3 and 16. 16 is bigger than 4. Not that what we did was wrong, okay? And if you did what I did here, it's perfectly fine, so long as you look at this number here and you ask yourself, can I do it again? And if you can do it again, you must do it again. You keep going until there's nothing else to do. Answer your question? All right. Let's go ahead and cut the video here and say bye, everyone.
Bye.
All right.